Hello students, last time in the last video we have studied how the chemical reaction takes place, and you must have seen that video where I have shown you 3 activities. When class will start, hopefully you people can also do the same activity. Now let us understand how the chemical reactions can be written in a word form. So last one we have studied about the chemical reactions. How can I identify whether a chemical reaction takes place or not? For that, we have seen from the activities, number 1, it was change in the state. Change in a state. Second, maybe there is a change in a color, where we are seeing I have added 2 liquids that both of them were colorless and converted into a yellow color. That was the second point. The third point was evolution of a gas. Very, very important things. Evolution of gas. Now, which one was that? Where we have added the magnesium strip in a dilute HCl solution, and you have seen that bubbles coming out, and that bubbles were nothing but the gas, and that gas is hydrogen gas. Yes, the question arises, how can I come to know whether the gas is hydrogen gas? So for that we need to do a test, and the test is like that hydrogen gas burns with a pop sound. Okay, but that is not visible over here, and that's why we have not done that. We will see that last one, and then there is a change in the temperature. This is very, very important, the change in the temperature, which we are going to discuss further ahead in our chapter. Okay, change in the temperature, it means when a reaction takes place. It's very simple. Let's check it in a different way. If I'm going to rub my hand, what will happen? Due to the friction, heat energy is liberated. It means there is a change in the temperature. But does it call a chemical change? No. Why? Because my hand remains same. No chemical change takes place over there. But when you add HCl, okay, in the HCl dilute HCl solution, if you have add a zinc metal or a, let's say, magnesium metal, then what happens? It's liberate hydrogen gas. Along with it, it evolves some energy, and that energy that's lead the change in a temperature. Okay, so now let's see how can we write down the chemical reactions into a chemical equation. So we will study now how to write chemical reactions into chemical equation. For that, let's take an example. So very simple example, the activity number 1. What was the activity number 1? We did the activity and it was very nicely went over there. And you have seen the magnesium strip was cleaned via sandpaper and then burned. And what we get it? We get it as white dazzling flame. So what do I have? I can write down in this way. Magnesium, it was a metal, ribbon, plus, yes, combustion, burning. What is the essential thing for burning? The essential thing for the burning is oxygen. And without oxygen, nothing can burn. So exactly the oxygen, what we get it from our atmosphere, written in the form like this: oxygen, magnesium plus oxygen give me a new compound, magnesium oxide. If you have observed on that day, there was white color substance after the burning of magnesium strip. We got it in a watch glass. That was the substance which we called it. Now, this is what we called it as a word equation. What is it called? Word equation. When a description of a reaction written in equation in the form of words, then that equation is considered as a word equation. Let's see what are these things. How can we identify different terms used in this condition? Let's say this color. So the things which is present over here right now, on the left hand side of the arrow, are considered as reactants. It means the substance before the reactions are considered as reactants. Reactants are here. In this example, magnesium and oxygen are the reactants. Now, what is formed at the end of the reaction? At the end of the reaction, I got something new, which is called the magnesium oxide, and in chemistry we call it as a product. We call it as a product. In this case, we have only one product. It may be possible that we have more than one product. Above arrow, there is a one sign called delta. The delta means we are giving it hit. We are giving it hit. This is the triangle which we call as a delta. This is the arrow. On the arrow, right side of the arrow, right side of the arrow is a product. Left side of the arrow are the reactants. Okay, so this is called a word equation. Now, how can I convert this word equation into very simple form or in a very short form? So that can be written in this way. So how can I convert it into shorter form? In the simplest one, that word equation is converted in the shorter form in this way. Let's see. Okay, let it be here. Change the color so that we can easily identify what are we writing. Magnesium. The symbol of magnesium is Mg. The symbol of magnesium is Mg. Okay. Let's take a darker color. That darker color will be this, so that I can make it out very clear. Okay. So its magnesium is written like this: magnesium plus what is oxygen? Oxygen is written as O. But in 9th standard we have studied about oxygen. Oxygen is a gas, and dioxygen, it is also known as a dioxygen. Oxygen, O means it's an atom. But when we talk about oxygen present in the air, it is O2. It's always in a diatomic form. So the formula will be O2. This is already you have studied in a 9th standard. If you have not studied well in the 9th standard, please go through the concept of 9th standard again and again. If you have any question, you can ask me. I can solve it out. And I'm going to prepare one video on that also, how to form equations, how to form a formula, what are the symbols, how can we memorize the symbols. That I can prepare one video on it and I will show you. Now, this is what exactly. This is a word equation converted into shorter form. Shorter form can be written in the symbol. The symbol of magnesium is Mg. O2, oxygen is a dioxygen gas, so we are writing O2. What is the product? Product is MgO. Now the question comes, why 2 went off? Because oxygen has 2 valency. Oxygen has 2 valency, and when it gains 2 electron, it is converted into oxide, and that's why we are writing oxide. This is what 9th standard concept which we have studied, how to write down the molecular formula. Okay, so this is what it is. This is a word equation. This is written in a shorter form, but this is not yet over. What I can mention, I can even mention the state of element or the state of substance or the state of reactant and the state of products. So what is this? Magnesium, as you have seen, it was a strip. So strip was in how which form? It was in a solid. So I can write down the abbreviation small s. The small s is very, very important. It tells us about, okay, the reactant was in a solid form. What about oxygen? Oxygen was present in air, and that's why we write it down as a G, gaseous form. And this is magnesium oxide, which is also in a solid form, which you have seen a white color powder formed over there at the end of the reaction. And at the end, what can I write down? Whenever I write an equation in this form, I must write down its equation in this form. I have to inculcate a habit of writing name of element or name of substance or molecule under it, and this is how my first video on how to write chemical equation on chemical reactions into chemical equations with the help of example we have seen this. So these are the very, very important things which we have to see. The very first topic of the chapter is chemical equations. Chemical reactions can be converted into chemical equations. Chemical equation can be represented with the help of such a product where we have written this is my word equation, which I can call it as a word equation. I can write it down as this, as a word equation. This is word equation. Okay, and this is the shortest form of the equation which I am going to make it down like this way. so that it can be easily understood by you. Up on the left hand side of the arrow, they are considered as the reactants. On the right side of the arrow, they are considered as the products. So it is very simple to understand what are they. And this point, the arrow pointed on this side, it means the reaction is going in a forward direction. The reaction is going in a forward direction. So this is what chemical equation, and how can we write down a chemical equation? This is what we have studied in this video. Let's take one more example and then we can conclude today's session. Okay. Activity number 2, which we have studied. What was the thing? It was like the two solutions we have taken. You can easily access it from our textbook. That what was it? It was the first thing that we were talking about. It was a lead nitrate solution. The solution of lead nitrate. Okay, it's a lead nitrate solution. That in the test tube I have taken a lead nitrate solution where I have added potassium iodide solution. Potassium iodide solution. When these two solutions mix together, what happens? I get one new compound that is called lead iodide. Lead iodide and plus what I have? I have potassium nitrate. Potassium nitrate. Now this is very interesting. This is really an interesting thing to understand. This is my body equation. How can I convert it into shorter form? So to convert it into shorter form, let's go for the concept which we have studied in the 9th standard. How to write down the equation, the formula, chemical formula of a substance. This is a substance. The substance is called as a lead nitrate. So lead, that is called Pb. Why the symbol of lead is Pb? Because its Latin name is plumbum, and plumbum stands for Pb, and that's why Pb comes. And nitrate, nitrate is NO3 minus, which you have studied. So this, the valency of NO3 minus is single, and lead has plus 2 valency. So I can write down lead nitrate PbNO3 twice plus K. Potassium is kalium, is also known as a kalium, and that's why we write down potassium. Symbol of potassium is K, and iodide is I. So it is Ki. And then lead iodide, lead is Pb, and I is 1. So I is 1. So I will write down PbI2, and then the last and the final potassium nitrate KNO3. These are the solutions which we are talking about. This is the word equation, activity 1.2. The word equation is lead nitrate plus potassium iodide converted into lead iodide and potassium nitrate, which we can easily write down in this way. Lead nitrate plus Ki, PbNO3 twice plus Ki gives PbI2 and KNO3. Let's see. Okay, what are the products over here? We can easily make it out from the equation over here. These two are the products. The first product is lead nitrate, which already I have studied, so written. So these two are reactants, and these two are my products. They are my products. You can easily see from here, they are the products. So what is left out? In the previous one, we can see here, the what was created here, it was like the symbol, abbreviations given over here. S, small s, G, and small s. What are they? These abbreviations are very important because that shows, what does they show? They shows me the state of substance or reactants and product. They shows me the reactant, substance and product. Here I am going to write down AQ. Now what is AQ, which I am going to write down over here? When you have an abbreviation S, it means solid. It means solid. When you have abbreviation L, it means liquid. When you have abbreviation L, it means liquid. When you have abbreviation G, it means gas. And when you have abbreviation AQ matlab aqueous. What is aqueous? Aqueous का मतलब क्या होता है? The solution which is prepared in water is known as aqueous solution. It means okay, we have a lead nitrate salt is dissolved in the water. That's why I have written aqueous. Same way, potassium iodide is written in AQ. But when I got a yellow color substance that was dissolved over that. This is PPT, and the PPT can be written. It is in the solid form, so I can write it down as a solid over here rather than a PPT. What is PPT? It's called precipitation, and this is what in the aqueous form. This will remain in the aqueous form, and this is how I can write down one equation like this. So dear students, today we have studied about how can we convert chemical reactions into a chemical equation and how can we write a chemical equation. So these are the few things which we have to take care of it. What is it? On the arrow, the right side arrow, the arrow pointed towards it, it means it is going on the reaction, forward direction. The substances present on the left hand side are considered as reactants. Substance present on the right side of the left side, substance present in the left side of the arrow are reactants, and the substance present in the right side of the arrow are what? Products. And the abbreviations are very, very important. The abbreviation shows the state of a substance, So this is what we have. Next time we will study how to balance chemical equation. Very, very important thing you have to do is that go to the chapter, the standard 9 atoms and molecules chapter, where the last portion is given about how to write a chemical formula. I'm going to send you one PDF file where you will find out radicals matlab anions and cations, and you have to frame at least 100 of the compounds name with the help of a valency. That topic is very, very important. I can prepare a small video on it and I can post it on your WhatsApp number, so we can have it on the next week. But please do this thing.